Hello everyone, I'm Suhasini. Welcome back to my channel Learn with Suhasini Shinde. In the very last class we have discussed about we have derived the electric potential expression for the electric dipole when it is kept in some electric field, right? In today's class we'll be discussing about the conductors, that is, and the properties of the conductors, right? You think what conductor is? Conductor are the substance or the materials which allow the electricity to pass through them, or in the other words you can say that conductor is a material which allows the flow of the electron into it, right? Particular substance are called as conductors, right? For example, you can take, there are so many conductors, right? Silver, gold, copper, and many more conductors, right? And then right now what are the properties of the conductors? The very first property of the conductor will be charges are always retained on surfaces, right? Whenever you charge any conductor, right, say if at all you are charging any particular body, say any conductor, right, the charges are always segregated on the surfaces, or they are retained on the surface. For example, this is a conductor. If at all you have charged, then all the charges are segregated on this particular surfaces, and hence there is no charge that is flowing into the conductor, right? So you will be always finding any diagram with respect to the charged conductor, they show the presentation of the conductor with charge is always the surface charged, that on the surface you retain the charges, right? This is how the diagram shows, right? And there is no charge that is present inside this particular conductor, right? Now this is the first property. What was the first property? The charges always retain on the surface of the conductor is the first property of the conductor, right? What is the second property? Second property is electric field inside the conductor will be equal to 0. What does this statement means? Electric field is equal to 0. See, wherever there is charge, there is electric field lines, right? If there is no charge, then there is no point of electric field, right? So what does it mean? Electric field are not present, there is no charge, right? Charge is equal to 0. Inside, I'm talking inside the conductor, right? These are on the surface of the conductor. Inside the conductor, charge will be equal to 0. Then what does it mean? When there is no charge, then there is no electric field, and hence electric field at this particular point will also be equal to 0. Did you follow, right? The first property was the charges retain on the surface. The second property is the charges or the charge is equal to 0, and there is no electric field inside the conductor, right? Now third will be the direction of the electric field will be always perpendicular to the surface, right? The direction of electric field will be always perpendicular to the surface. Whatever surface you take sphere, you take a line, you take volume, right? You take any conductor, cylinder, anything, right? Any, irrespective of any shape and size, right? The electric field lines are always perpendicular to the surface. Say for example, if at all you are considering a sphere, right? Now at any point you consider, the electric fields are always perpendicular. Now this line is perpendicular to this surface, this line will be perpendicular to this surface, this line will be perpendicular to this surface, right? The electric field lines are always perpendicular to the surface of that particular conductor, right? If at all the charges are positive, then the electric field lines will be outward, right? Now if at all this is a sphere which has a positive charges on its surface, if it has a positive charges, then electric field lines will be moving outside. I said you in the very last classes, whenever we have electric field due to the positive charge, all the electric field lines are moving outside the charge, right? If at all the electric field is because of the negative charge, then all the lines will be moving into the negative charge, right? Now if at all this particular surface is being covered or it is retaining the charges of positive, then what is the direction of the electric field? It is outward. For the same sphere, if the negative charges are retained on that surfaces, then the direction of the electric field will be again perpendicular, right? Perpendicular to the surface, but this time their direction is inward, that is for the negative charges. Is this clear? Now the fourth property is electric field on any surface, say for example this is surface, electric field at any point on the surface will always be equal to, electric field will be always equal to sigma divided by epsilon naught. What does this statement means? If at all you want to calculate electric field at any different point on the surface, at any particular point you always get electric field as sigma divided by epsilon, where sigma is called as charge density, right? Whichever point you take, that particular point, at that particular point electric field will be charge density by epsilon naught, right? Now this has to be proved. This is not just an equation that is blindly accepted. This has a proof here, right? Let us prove the fourth property, right? What was fourth property? I said you electric field at any surface point, at any point on the surface will be always equal to Q divided by epsilon naught, right? Now this has to be proved. Now this we will prove with the help of example, right? Now say for example you have any particular shape over here, say sphere or any shape, right? And we are placing a Gaussian surface at this particular point, right? A cylinder is put here in this particular surface, right? When the cylinder is put into this particular surface, it has three main regions into this particular section. That is, this is the surface area 1. Let us consider this area as 1, this surface area as 2, and the cylinder touching this particular point is 3, right? You have three surfaces, 1, 2 and 3, right? I said you, say for example this is a conductor. Whenever a conductor is charged, whether it is charged positively or whether it is charged negatively, all the charges are retained on its surface was the first property, right? And hence these charges are shown on the surfaces but not inside. Inside the conductor, electric field is also 0 because charge is 0 over there, and hence you write charge will be equal to 0. Due to that, electric field will also be equal to 0, right? Now why are we doing all this thing? We want to prove a Gauss law. What does Gauss law says? Electric point or electric field at any particular point on the surface of the conductor will be equal to the charges to that of the epsilon naught, right? This is the equation. That was the fourth property. Now we are proving this particular equation. How do? We take a conductor and we put a cylinder into it which has three surfaces, mainly 1, 2 and 3 surfaces. All the charges are segregated on the surface, and within the conductor, inside the conductor, the charge will be equal to 0. There is no charge and hence there is no electric field. Electric field is also equal to 0, right? Now what does the Gauss law states? Now this is, whenever I put the integration and this 0 like this, it means a closed surface, right? Whenever I write this notation, then that particular notation means a closed surface. We always consider closed surface when we take Gauss law into consideration, right? Now the electric field in the closed surface will always be equal to the charges to that of the epsilon naught is the Gauss law, right? Now we have three surfaces here, surface 1, surface 2 and surface 3, right? We write a equation for all these surfaces, right? Okay. Now you consider always a differential element. In the very last classes we have always seen whenever we are considering a closed loop or a closed circuit, right? First we consider a very small element into it, then we generalize to the whole surface, right? In the similar lines, what we do is, the very first one is, you need not consider any particular point here. Why? Because whatever you consider here, whatever you take, whatever small elementary area you take in this particular region, it will always be equal to 0. Why? Because there is no electric field, so there is no point in calculating anything here in this particular region, right? For the second surface, you take a very small element here, that is a ds element, right? Now for this particular element, small element, you drop a surface vector, right? I said you a surface vector or a area vector will be always perpendicular to the surface or the area considered. If at all the area is considered this direction, then the surface or the area vector will be perpendicular. If at all it is considered like this, then it will be perpendicular here, right? Now consider this is as a surface vector. Okay, considering a small element over here, that is ds, we consider a surface vector perpendicular to it. Now this space is like this and we consider a perpendicular vector here, that we have denoted it by n vector, right? Now we have another vector, that is electric field due to the charges that are present over here. What is the direction of the charge, or what is the direction of the electric field here? Due to the positive charge, the electric field lines are moving upwards, right? Now what is the angle that is made between the surface vector and the electric field here? There is no angle made, right? And hence theta is equal to 0 degree. Why? Because the surface vector is also moving upward and the electric field due to the positive charges is also moving in the same direction, and hence they are moving into same direction. They have no theta value, or they have no angle made between them, and hence theta will be equal to 0, right? Now for example, you consider a very short or small element here for a surface 3, right? Again you have two vectors now, one is surface vector and another is electric field, right? Now this is considered like this. This surface is considered like this. How will be the surface vector here? The surface vector is like this. The surface vector is like this, and the electric field at that particular point is also in this direction, right? The electric field in this particular point is moving upward due to the positive charge present here. Then what is the angle between the surface vector and the electric field here? It is 90 degree, right? And for the first surface you need not consider any particular area. Why? Because anything you consider, it becomes 0 over here, right? Now for all these three things you write this particular equation, right? That is for the first surface we write electric field for the closed surface 1, right, ds cos theta, plus electric field for the closed surface 2, that is cos theta for the 2, right, plus electric field for the closed surface ds cos theta will be equal to charges present into that surface to that of epsilon naught, right? Now what is EF ds cos theta for the electric field in the first region? It is 0. Why? Because there are no charges inside the conductor, there is no electric field, and anything that you consider inside the conductor will always be equal to 0, and hence this is 0, right? Now what is theta at the second surface? Now theta here, theta is equal to 0, right? You put theta is equal to 0, then what cos 0 is? It will be equal to 1, right? So this is 0. For the second one we are getting, that is electric field ds cos theta 0, it is 1, right, plus, right? Now for the third, this is the third area. Okay, for the third area theta is 90 degree, right? So how do you write it? So this theta is equal to 90 degree, right? Cos 90 is equal to 0, and hence the whole term becomes 0, so it is 0. That is qin divided by epsilon naught, right? There is only one term that we are getting, that is a second surface where theta is equal to 0, that EF ds, right? Now integration of electric field ds will be equal to qin divided by epsilon naught, right? Did you follow up to this particular point, right? Now electric field at any particular point will be equal to the same, right? So take this electric field outside, and it is ds is equal to qin epsilon naught, right? What is this ds? This ds is a very small elementary part in this surface 2, right? If at all you want the whole thing, then the this can be considered as surface, or it can be considered as area, right? So you can write integration of this ds will be equal to, if at all you consider the whole surface or the area here, you can write it as a, right? That is qin divided by epsilon naught, right? Now this qin, that is, what do you mean by qin? Any charge that is present inside the surface, right? We are not bothered about the charges that are present outside the surface. qin means the charges present inside the surface, and only that are considered, right? Now this qin is again further expressed in terms of charge density, right? What is the charge density given? Sigma will be equal to q divided by that particular area. sigma charge density can be defined as charges present in that particular area is called as, that is charge density sigma, right? Now this Q can be expressed in terms of sigma and A, right? So substitute this value in this equation. So it will be E A Q I N in terms of sigma A divided by epsilon naught, right? Now this A get cancels, and what is remained, that is electric field, will be equal to sigma divided by epsilon naught. This is what we needed, right? This is what exactly we needed, right? What does this statement says? Now you do not confuse, it is electric field, right? Now what does this statement says? Electric field at any point on the surface of a conductor will be always equal to the sigma times of epsilon naught. This was the proof to make you understand the fourth property of the electrostatic conductor. Is that clear, right? Now the things are not just said. See, every thing that you study has a particular logic. The things are not just explained like that, right? When I say this electric field is equal to Q divided by epsilon, it is been derived. It is proved in that particular manner. And right, this is the proof for this particular equation, right? This was the fourth property. Now what is the fifth property of the conductor? The fifth property says the electrostatic potential, that is the potential energy of the conductor at the surface and inside remains constant. What does this mean? If at all you have this is a conductor which is charged for positive, right? Say for example you have a point here whose potential, this point is A, and consider another point in this region inside a conductor, say B, right? Now there are 2 points, one on the surface, that is A point. We consider another point inside the conductor, that is point B, right? Now what is the potential at this particular point? It can be VA, right? Now what is the potential inside this? We can consider it as VB, right? Now what the fifth property of the conductor says is the potential on the surface and the potential inside the conductor is constant, or it is equal. Now you have to prove this for the fifth property, right? Now what you do? You take a charge. Now proving this particular thing, you take a charge, you keep here on this point A, right? Then you take that particular charge and have some work done in moving it at the particular point B, right? You do not confuse. You just take a charge, put it on the surface at the point A, then you move it in the point at the point B, right? Inside the conductor there is no electric field. Do you agree? Why? Because there are no charges present and hence there is no electric field. Electric field is 0, right? Charges, due to charges are 0, electric field is 0. Now there is a charge, right? Now you bring this particular charge from the point A to the point B. Some work has to be done, right? When you do some work, when there is no electric field around or no energy is present, what is the work done in moving this particular charge from point A to B? The work done is 0, right? We have seen in the very last classes, whenever you move a charge from a point to a region of no electric field or no energies, right? There is no energy and no electric field. If at all you are moving a charge into any region, into that particular space, then the work done for that particular charge will be equal to 0, right? So we had we had a formula for that. If at all you remember, we had this equation in terms of potential energy, that is final potential minus initial potential to that of work done in moving a charge A to B to that of that particular charge, right? Now what is the work done in moving the charge from A point to B point? This is 0, right? Why? Because there is no electric field, then you can easily move or shift any particular charge from one point to another point, right? Now this is 0, the entire term becomes 0, right? Now VB minus VA is equal to 0, therefore VB is equal to VA. Then what does it mean? The potential remains constant on the surface and inside the conductor, right? VB here and VA here at this particular point, whatever the value of the potential is, it remains constant whether you consider it on the surface or you consider within the conductor, right? Then what does this mean? inside the conductor, right? Say for example, you have a conductor, right? Inside the conductor, electric field will be equal to 0, charges will be equal to 0, but the potential will be equal to that of the any point that is considered on the surface, right? Whatever surface potential is present, or whatever the value of the potential that is found on the surface will be exactly equal to the any point inside the conductor, right? Is this clear? There are 5 important properties of the conductor that you have to understand. The very first property was the charges always reside on the surface. The second property was the charges inside the conductor is 0. The third property was the charges or the direction of the electric field line is always perpendicular to the surface. If at all we consider a positive charge, then it is moving outward, and if at all you consider negative charge, then it is perpendicularly moving inward, right? The fourth property will be electric field at any particular point on the surface area will be given by Q divided by epsilon naught, and hence we have proved for that. And the fifth property is the potential energy or the potential difference on the surface and the internal and inside the conductor remains equal, that is VA is equal to VB, which is proved like this. Do you remember now? Everything is properly understood, right? This was all about today. You please do share. If you like my channel and if you like the way I teach, you please do subscribe to my channel. Share the link with the friends and families. Your one share can really help one particular student if at all he genuinely wants to understand the things, right? A playlist for the very first chapter has been created. If at all you want to know or to study the entire electric charges and field subject or the topic, you can go to the playlist and you have 10 different videos of that particular chapter. You can play it all, and I assure you that you will be understanding it completely, right? You please do support, and if any suggestion from your side and how the videos are reaching out for you people, if at all you could comment or suggest me something in the suggestion or drop a message in the comment box, then I'll be very grateful for all you people, right? And the notes for this particular chapter will be found into the description box, right? I have a handwritten notes for this, all the things, right? Exactly what the things that is being explained in the classroom, that is in this particular videos, will be followed that by the handwritten notes, right? You can please go to my website, download the notes, and then after looking into the videos, if at all you study the similar lines, then it will be very helpful and very easy, and it consumes very less time of yours, so that you can dedicate your other time for different subjects also, right? And let me know if at all any changes or any improvements has to be done, and keep visiting my channel and do support, and thank you so much.